Today's video is on the problem related to Taylor series, and this topic is from complex power series. And now in today's video I am going to expand f of z is equal to cos z in Taylor series about z is equal to pi a. See, in the solution, so it is given as f of z is equal to, this is cos z, and z, the region here z is equal to pi I. So what is this Taylor's expansion? So according to the Taylor's expansion we have, so according to our Taylor series expansion, so we have the series as f of z is equal to, so this is f of a plus z minus a by 1 factorial into f dash of a plus this is z minus a whole square by 2 factorial into f double dash of a plus and so on. Clear? So in this I am going to substitute f of z as cos z. So f of z as, this one is cos z, and a value as pi I. From this region a as pi I and f of z as cos z. Now this will become cos z is equal to, so this will become cos z is equal to f of pi I. So this value will be f of pi I into z minus pi I into f dash of pi I plus this is z minus pi I whole square by 2 factorial into f double dash of pi I plus this is z minus pi I whole cube by 3 factorial into f third derivative of pi I plus this is z minus pi I power 4 by 4 factorial into f fourth derivative of pi I plus and so on. Now I need the values of, in order to substitute I need the values of f of pi I, f dash of pi I, f double dash of pi I, triple dash of pi I and f fourth dash of pi I. For that we have f of z is equal to, so f of z is equal to, see, this is cos z. So what will be f of pi I? So f of pi I will be cos of, in place of z we have to write pi into I. So this is clearly, so cos pi I can be written as cos of hyperbolic function of pi. So what will be the cos h pi value is equal to minus 1. Therefore f of pi I value is equal to minus 1. Clear? And the next thing here is f dash. So we have to make one derivative out of it. For cos z, this will be minus sin z. So f dash of pi I value will be minus sin pi I. So here, if you transform into hyperbolic function, so for I, so I comes out and sine hyperbolic function of pi. So sine n pi value is equal to 0. Therefore we got f dash of pi I value as 0. Clear? So f dash of pi I value is 0. And the next here we have to calculate f double dash. So f double dash of z is equal to, already this is minus, and for sin z, so this will be cos z. Therefore f double dash of pi I is equal to minus cos of, in place of z write pi I. So here there is no need to bring I outside for cos, and we can straightly write as h pi. So this value for cos h pi value is minus 1. Already this is minus, the value here is plus 1. Therefore the second derivative of pi I value is equal to plus 1. So the value here f double dash of pi I value is equal to 1. And therefore the third derivative here. So if you observe this one, so what will be third derivative? Third derivative here will be, so f third derivative of z is equal to, so this is minus, for cos z this will be minus sin z. So therefore the third derivative of pi I value will be sine of pi I. So this will be I times of sine h pi. So which is equal to sine n pi value is equal to 0. Therefore the third derivative of pi I value is equal to 0. The third derivative of pi I value is equal to 0. For sine I comes out and for cos it doesn't comes out, and therefore the fourth derivative of z is equal to, for sin z, The derivative is cos z. The fourth derivative of pi I. In place of z, if I write pi I, and see, this will be cos h pi, and the value here is minus 1. Therefore, the fourth derivative of pi I value is equal to minus 1. Therefore, see here, so the values I am writing: f of pi I, f dash of pi I, f double dash of pi I, f triple dash of pi I, and f fourth derivative of pi I. So I'll mention all the values here. So what is f of pi I? So f of pi I value is equal to minus 1. So I'm writing this as minus 1, and f dash of pi I value is equal to 0. F double dash, so f double dash of pi I value is equal to 1, and next one here, f triple dash of pi I value is equal to 0. Fourth derivative of pi I value is minus 1. So now what is our Taylor series expansion? So cos z is equal to, so here cos z is equal to f of pi I plus z minus pi I into f dash of pi I plus z minus pi I whole square by 2 factorial into f double dash of pi I, and next one z minus pi I whole cube by 3 factorial into f triple dash of pi I plus z minus pi I power 4 by 4 factorial into f fourth derivative of pi I plus and so on. Therefore, cos z is equal to, see here, cos z is equal to f of pi I value is equal to minus 1 plus this is z minus pi I into the first derivative value is 0. Next, z minus pi I whole square by 2 factorial into this value is 1 plus this is z minus pi I whole cube by 3 factorial into, so the next value here is f dash, f dash, f double dash, f triple dash. So f triple dash value here is 0. And next one, z minus pi I power 4 by 4 factorial into the fourth derivative here is minus 1. And therefore cos z is equal to, this is minus 1 plus this is z minus pi I whole square by 2 factorial, and this is 0, and minus z minus pi I whole power 4 by 4 factorial plus and so on. So this is the expansion for Taylor series expansion of cos z, when the region is given z is equal to pi I. Thank you so much for watching, and this is the question. So f of z, we have to take cos z, z is equal to pi I. So in place of 8 pi I, and in place of f of z as cos z, and after substituting we need all these values. For all these values, these are the values found out, that is f of pi I, f dash of pi I, f double dash, triple dash, and fourth derivative, and after substituting we got the final answer as this. Thank you so much for watching and staying till the end. So I'll be uploading so many videos related to this series. Please watch the playlist, practice, and pass it on to your friends, and it will be very helpful to this video. And thank you so much.